Ocean-going ships' emissions are a significant problem. According to AB, a global engineering and environmental firm with its headquarters in Zurich, Switzerland, maritime transport currently accounts for close to 3% of annual carbon dioxide emissions and is expected to rise to 17% by 2050 if no adjustments are made. Technology related to hydrogen fuel cells is one area of focus for AB. According to the corporation, fuel cells produce energy via an electrochemical reaction. Since the fuel cell transforms fuel directly into energy and heat, combustion is avoided. Fuel cell technology come in a variety. The proton exchange membrane fuel cell is one of the most promising zero-emission technologies. Through an electrochemical reaction with oxygen, the PEM fuel cell turns the chemical energy from hydrogen into electricity, producing only clear water and heat in the process. Compared to combustion engines, fuel cells are more efficient, and the technology enables energy to be concentrated more densely than in petroleum fuels. The entire energy cycle will be clean if renewable resources are used to create the hydrogen fuel, creating a real zero-emission fuel. This week, the company said that it will work with the Dutch-based Samskip Group, a multimodal shipping company, and India's Kochi shipyard to construct two 135-meter-long container ships, each of which will be powered by a 3.2 MW AB hydrogen fuel cell system. Each ship is anticipated to reduce annual carbon dioxide emissions by 25,000 tons. Pressure to cut carbon dioxide emissions and support other sustainable technology is intense in the maritime sector. To satisfy more stringent emission standards, other energy sources like batteries and hydrogen fuel cells will be required. As both batteries and fuel cells produce unregulated DC voltage, a variety of configurations can be used to connect them to the vessel's electrical system, each with advantages in terms of maximum source-to-load efficiency, overall system performance, size, weight, and price, according to AB. AB will provide the two new container ships with a complete hydrogen fuel cell power distribution system, making them the first of their kind. The 135-meter ships were constructed by Kochi Shipyard Limited, the largest shipbuilding and maintenance facility in India, and are scheduled for delivery in 2025's third and fourth quarters, respectively. Between Oslo Fjord and Rotterdam, a distance of about 700 nautical miles, both ships will be in service. AB's entire package comprises the new, more compact version of its onboard DC grid power distribution system, which will guarantee the best possible use of energy on board, in addition to the integration of hydrogen fuel cells. The ships will also have control and automation technology from AB's energy storage solution, assuring smooth operation of the equipment on board. The vessels will have 24/7 remote assistance thanks to AB Ability remote diagnostic systems, which will improve safety and performance. Through an electrochemical reaction, fuel cells convert the chemical energy of hydrogen into electrical energy. The entire energy chain will be clean if hydrogen is produced using renewable resources. One of the most promising approaches to advancing the shipping industry's decarbonization goal is hydrogen fuel cell technology, which has the ability to drastically lower greenhouse gas emissions and boost energy effectiveness. Each energy conversion results in certain losses. There is no way to avoid the fact that more conversions result in more losses. With batteries, renewable energy is captured and later used to drive functional motors. Lower losses result from fewer conversions. However, with today's battery technology, it would be difficult to fit enough batteries onto a container ship to operate it for 700 nautical miles with a sufficient power reserve to address emergencies while underway. To minimize shipping emissions, balancing the ideal with the practical, fuel cell-powered ships look like a good idea. Methanol, ethanol, or ammonia, which are also being marketed as means to reduce carbon emissions, are unquestionably preferable than fuel cells. And they are unquestionably preferable to diesel-powered ships that burn heavy bunker oil similar to tar. The International Maritime Organization's updated greenhouse gas reduction strategy, which calls for reaching net zero greenhouse gas emissions from international shipping by 2050 and a commitment to enhance the use of low-carbon fuels by 2030, is in accordance with the hydrogen fuel cell project. Finally, it should be noted that Norway is one of the world's major producers of green hydrogen due to its availability of hydroelectric electricity. The entire purpose of doing this goes out the window, or out to sea, depending on the situation, if the hydrogen required to power hydrogen fuel cell powered ships is generated by conventional techniques from reforming methane gas.